Hello there, it's Jay here from Jay's Vintage Junk, and today I'm playing about with my Toshiba T1200. Now, I did show this on the channel back when I got it, not this February, but actually the February before. I treated myself for this as a bit of a birthday present. Reason being, I do like my early Toshiba laptops. And this is actually a model that I had when I was a kid, back in the mid-90s. I think I had one of these about 95ish or something. So, you know, second hand when I got it. These came out in 1987, along the same time as its smaller brother here, which I've shown this on the channel quite a few times. This is my Toshiba T1200. So essentially this is the smaller brother of the T1200 there. They both came out in 1987. So this is a bit more of a lighter weight machine. This is 4.7 megahertz, just a standard XT clone laptop, XT clone. The T1200 that we're having a look at here, this is a Turbo XT. It runs at nearly 10 megahertz. I think it's like 9.5 megahertz or around about there. It is still an XT class machine. It does have 1 megabyte of RAM on board, 640k as its standard system RAM, and then it has a an upper bank of RAM which you can actually use as a RAM drive and things like that in the system. They were, you know, quite interesting systems. This isn't exactly the same as the one that I had. Mine was actually a slightly higher model than this, because mine had the single floppy drive in a 20 megabyte hard drive. This one's the twin floppy drive version, but it's not really such a bad thing, because those hard drives were getting iffy by like the late 90s, and I don't think really any of them are really working anymore. And they weren't like a standard IDE interface or even a standard MFM interface. They were actually something that Toshiba brewed up themselves, and they were proprietary to Toshiba machines. We're probably actually better off now with this machine as just something to play about with. We're just having the two floppy drives, which do work in this system. Last time we played about with this, like I said, when I first got it, and I unpacked it from when I bought it. We did attempt to power it up then, and the only way I could actually get it to power up was with an old drill battery, substituting from the actual battery in the machine. Since then, I pulled it out a few times. Unfortunately, I'm sorry, but I didn't do any videos on it. It was just, you know, when I had a minute and I've been fiddling about, I've pulled it out and done the odd bit and bat on it. And one of the things I did do was take the original battery and put it on my bench power supply, current limited supply, and tried trickle charging it. And amazingly, that battery has actually come back to life, and it is working. Once I put the original battery back in it and actually connect it up with 12 volts, the computer itself was able to charge the battery. I'm actually really surprised. I was expecting to have to do some work to the power supply circuit in the actual laptop to get that to work, because when we first tried it, none of that would work at all. But now I got the battery working. Like I said, once I got the battery working, and I have had to lash up a power adapter to get 12 volts into this, a couple of amps. The computer started to charge the battery to the point where even the battery indicator light after a while went from red to green. So it took about 8 hours to give the battery a full charge. Now I don't know how good the battery is going to be in a discharge. I've not actually tried that yet, but it is actually functioning, and this battery's got to be, I mean, the laptop's from 1987, so when's the last time that they could have made like a replacement battery from this? Say 1997. So I'm guessing at the very, you know, least this battery could be from say like 97, but there's a good chance this might be the original battery from this laptop. So it's, you know, over 30 years old, and it still does seem to actually work. It gets slightly warm as it charges. It doesn't get hot, it just gets slightly warm, and it appears to be working. I've actually got the laptop up and running at the moment, not that you can see it, and that's one of the reasons that I'm doing this video today, what we're going to take a look at. One of the issues with this laptop is the screen. It's actually got lemmings running on it at the moment, not that you can see this. I can just about make it out on the screen. But if I flip over onto my little monitor here, so we press function and end, you can see we've got a nice clear, albeit in black and white, because this only gives a black and white composite output, unfortunately. It's a shame. And it is an NTSC output rather than PAL, because if I switch my little monitor into PAL, we just get a rolling screen. I have to actually switch my little monitor into NTSC mode to get a locked picture, but it is in black and white. I was always wondering whether when they said that they output a black and white image from the composite on these, whether it was actually just NTSC and there was actually really colour there if you used it on an NTSC screen, but no, it isn't actually an NTSC signal, and it is just black and white, which is a little bit of a shame, because that would be nice to be able to run colour composite off one of these. And I am wondering whether there's possibly a way of doing a mod to the computer itself, and possibly able to get colour composite out of it, because that would make these really nice for a little bit of like early retro gaming. With it being the Turbo XT version as well, like something like Lemmings, it actually runs Lemmings really quite nicely. Anything that was around from a kind of that era, you know, 88, 89, something along that, will actually run quite nicely on this. Especially if it can run CJ graphics quite reasonably, you know, it'll look okay. But the main screen itself, as I've said, is let's get it back onto the screen. As you can see, you can barely see anything. Now I can mess with the brightness control, but one of the problems with this laptop and when I got it is the contrast control on the side is actually missing. There's nothing there at all. You can see the pot inside, but there's not actually anything to slide it with. So what I thought we'd do in this video is basically, because I've not even opened this computer up yet, is have a look inside it and see what we can do, see if we can actually fix that contrast control, and perhaps see if we can get a little bit of a better image out of the actual screen. Unfortunately, it will never be perfect, because this screen has started to degrade. If you look in the corners here, it has actually started, basically the laminations inside the LCD have started to come apart and fail. So this part of the screen there, in the very top corner there, no longer work. But the rest of the screen does. It actually is still usable at the moment. So I don't want to start looking at, you know, putting another screen in it at the moment, although that's something I will possibly think of, you know, in the future if this screen starts failing completely and we can't find anything to replace it with that's period correct, or, you know, one off a scrap laptop that I could put in here. I have a feeling that all these are starting to go like this now. You know, in the future we could perhaps look at putting a modern screen in it, and perhaps even getting like colour, you know, colour CGA graphics on it or something like that, which would be getting a bit something interesting to play with perhaps in the future. But for now, I just want to see if I can get that contrast control working there, and see if we can perhaps get a little bit of more sharpness out of the actual screen, so it's more usable. Because at the moment, honestly, if I want to use this, unless I just want to look at some very basic text on the screen, I've got to connect it up to another monitor, and it does output a nice colour CJ output. I can plug into my CJ compatible monitor over there, and it's fine like that. But it would be nice to be able to use it with the actual screen, because at the moment, I'll just shut that down and turn off. At the moment, the actual screen on my the Toshiba here, which isn't even backlit, actually gives out a nicer display. Let's see if it's going to work on its internal battery without me having it plugged in. If you look at that, I don't know if you can make that out on screen, but it does actually give a really nice clear display even on. See if it'll boot now. There we go. I'll show you. you know, for something that's got absolutely no backlight or anything, it's nice and easy to read, that one. As where this is pretty horrendous to read. We'll switch that back off. Because the battery isn't brilliant in this. This is a battery that I had to rebuild just to get this laptop to actually work. Because these, unlike that laptop, this won't even fire up or do anything without an actual internal battery in it. And when I got this, the battery was completely shot, and I rebuilt the pack inside it. Actually using old second-hand cordless drill battery cells, and they weren't brilliant when I did it, so it doesn't last a massive amount of time on its battery, but it's fine when you have it absolutely plugged into the power. One day I will perhaps rebuild the battery in that with brand new cells, because I do use that laptop quite often. But we'll get reset, we'll get down on this, and we will have a look inside it, see what we can do with that, and see what we can see what we see inside that, see if we see any horrors in there, because like I said, this is not been opened by me yet. So back in a sec. Right, okay, there we go, we've got everything unplugged, and first thing we're going to do, let's get the meter in. I'm just curious to see what we've got on that battery. Seeing it actually went from red to green on the charge light there, so this should be basically a fully charged battery. It's barely even warm. It has been off for a little while now. Right, it should be 7.2 volts. So let's see what the when it's brought it up to. With it being fully charged, it could be slightly higher than that, to be honest. But let's have a look, see what this probably getting on for 30-year-old battery is actually showing. .2. That's about what I'd expect from a fully charged battery. So it'll be interesting to see how long that battery actually lasts. But it does seem to have fully charged, which is quite amazing, really, for the age of the laptop. Right, let's get that out of the way. And let's have a look at getting inside here. So we've got 2 screws, one there and one there. I'm fairly familiar with getting inside the T1000 because I've been inside mine a few times to do repairs. It's a very long time since I went inside a T1200. Right, I've got those 2 screws out there. Let's have a look on the bottom. And we still have the same awesome carry handle, although yeah, they've cheaped out slightly compared with the T1000. Also, these come out at the same time, but I much prefer the handle on the T1000. It feels more substantial with all the metalwork around it like that, as where the T1200 handle, it's there, but it just feels, it's, you know, more plasticky. It doesn't feel quite as substantial as that handle on the T1000. I think we've got a screw missing there. Hopefully I have something in my stack. Oh right, and we'll have to remember as well, so them 2 screws we took out from the other side are shorter than the screw I've just taken out there. Let's see about some of the others. That's the same length as that one I took out from there. Let's try this. That one doesn't feel right. Oh, there we go. It's coming out now. I'm not sure if we need to take that one out. That almost looks like some kind of earth bonding screw or something. There's some more there. I think those are possibly for the disk drive, although I'm not sure. Let's take that one out. Are we left any more? Is that it? Right, perhaps we do have to take, There's nothing under there. Let's have a look under the handle. We've got nothing under there. Actually, we do have to take that one out there. It does feel indeed the same as the others, and it's the same length as the others. Right. Let's just see if that's done anything. Aha. Right, so we seem to be up on that side, but there's still something holding us up over here. I can't see any screws around there. What you have to be mindful of is the plastic on these is starting to get, you know, to that age where it will break very, very, very easily. I've got just something round the top there. Let me see if I can find something I can just pry it with, which isn't going to cause any damage. There we go, got it. Right, let's open up, let's see what we have got. Okay, I'll have to open it that way. First things first is we've got a ribbon cable here going to the screen, which we will have to disconnect. Okay. Well, there was two there. Fortunately, they both come out together. So we can take the screen out of the way there now. Right, okay. So we've got a power supply section here. A little bit more advanced than it seems to be in the T1000. There's our battery contacts, our disk drive pack there, and what we want to look at now, where is that? So that contrast control there, so we're going to have to take that board out to be able to get to that and see what we can do about putting one on there. I'm wondering if I could basically take one off like a scrap Walkman or something, a CD player or something like that, and that might actually be able to be made to fit. Right, but we're going to have to get this board out of the way first so we can actually get down onto that. And I've just noticed that's a rechargeable battery. It doesn't seem to have leaked at all. I presume that's the CMOS battery, because these actually do have, you know, like quite an advanced CMOS actually, with a setup program you can run to configure the actual computer. Right, let's try and get this this power supply out of the way. It might be as well while we're in here to perhaps check some of these capacitors, because I didn't realise I had quite so many electrolytics on there. So it might be as well while we're in here to just have a check over of those. I'm going to need to disconnect that cable there. Out you come. That's being stiff. There we go. Gently get that out. That's very, very tight. The wires don't have a lot of play in them, so it's a bit, there we go. A little bit tricky to get out, but there we go, we've managed it. Now let's see where these go. Now that connector just goes right down to the board there, so that's nice and easy to disconnect. That might be, oh, poo. So does that come off? Because what we need to get, and I've just noticed something, I've just actually spotted something. Let me get some tweezers. I go and fish down here. I wonder if I can. There is the knob that's come off. So it wasn't missing it just got knocked inside the actual computer. Ah, so that looks like that does come off. Right, good. Because we need to get underneath that now to be able to. Right, does that mean the whole drive assembly has to come out? Oh, it looks like. Oh, fun. Right, okay. We're getting somewhere now. Where do you go off down to? So you're going off down there toward. Ah. So that's the backup battery there. Plugs onto the board there. So we can actually test the backup battery and see what charge that's got in it. Let's have a look here. Can you see that? Let me see if I can sneak you up a little bit so you can see a little bit better. And hopefully you can see what's on that screen there. So unfortunately I'm using the power supply that I normally use for my little monitor I use with the camera, was what I was using to power this. Right, let's go on there and go on there, and we've got, wow, 6.2 volts. So it looks like that battery's good. So that backup battery there looks like it's good. That's quite impressive. Right, we still need to get this out of the way though, so we can or actually we could leave all that connected to there. That goes to the charge ports there. That's connected from the main board there and the main board there. If we unhook this wire here, I think we can probably get the power supply and everything all out as one piece, and then we can get down to what we need to get to down there. There seems to be a screw here. Let's get that one out of the way. That's another short one. Now let's have a look, see. That's lifting up there. There's obviously some more screws we're missing. There's one at the back there. Yeah, so you're really discovering this exactly the same time I am. I've not done any research before I started making this video, so you can struggle along with me, to be honest. Now, do we have to pull that out? I think we might have to take the keyboard out. Or at least we'll slide it forward. Let's take the keyboard out so we don't risk damaging it. That pulls out easy enough, so let's get the keyboard out of the way. And believe it or not, we have individual micro switches. This isn't a membrane keyboard like you find on a modern laptop. Those are all individual key switches. I don't know whether they're anything fancy. Are them an Alps? I think they're an Alps key, aren't they? With that profile on them like that. Better not show anyone that, or they'll be getting these just to rip the keyboards apart. Right, let's get that out of the way, and let's see about moving. Do I have to get you out of the way? Interestingly, now we've got in here. Let me get you zoomed down a little bit so you can see a bit more what we're doing. There we go. So we've got a slot for a Masco processor there. I can't actually see the CPU up to now. It could even be one of these quad flat packs, because this is pretty integrated. It does use like low power CMOS versions of a lot of the parts. Not sure what that board there's for. It's Toshiba T5, is that some kind of like memory expansion board or something? Yeah, Well, can't see anything on it. Let's have a look at that. Ah, there we go. So that's our memory. I wonder if that could be upgraded. The possibility that could be upgraded, you know. Especially considering we've got all these there's sockets there, there's IC places there not being used. I'll have to look into that. That, I'm guessing, is where the proprietary hard drive would go. 2.5-inch proprietary hard drive. So it does look like you could indeed have this system. You could actually have had this system with the 2 floppy drives and the hard drive, which would have been really, really cool. But yet another backup battery there. While we're in here, let's see what voltage is on that. .6 volts, and I expect that's probably a 3-volt cell, so that's still there, that's still working. So unless this computer has been serviced before and all these batteries replaced, these are doing rather well for 1986. 1987, sorry. This one, yeah, no, 1987. Right, we've got that out of the way. Does that help us? That allows that to lift up there. Are we missing a screw that's been hidden under here or something? Because it doesn't seem to want to lift here in this portion. Oh, hang on, because it's got this. Right, so that's how the floppy drives get down to the main board. Right, okay. I see where you're coming from now. So we might have to just. What I don't want to risk doing is damaging this connector or anything, getting this off. There we go. Lift it up. Ah, that's out. It's always a little bit nerve-wracking when you're taking a system like this apart for the first time, when you haven't. Well, not for the first time, but it's such a long time. I can't really remember what I was doing. I think the only time I ever went inside that computer was to clean the disk drive, because the disk drive had stopped working. Right, am I missing anything? So we're all 3 there, that's all lifting up. So what is preventing us from... I think we're going to have to get this further out of the way. Yeah, we can unplug that there. We'll unplug that there. And we can actually get that power supply then fully out of the way, and we'll have a look at that in a minute, because I just want to sniff around those capacitors and see if we've got any chance of leakage. I can't actually see any trace of leakage on that board, and with no bulging caps or anything, but we could still have some leakage. What are they? The Nichicon capacitors, so they're, you know, good quality capacitors. Well, that doesn't mean, I mean, these things, like I said, are 30 odd years old. They may have started failing by now, so we'll have a look at that in a minute. Hopefully now, with that out. Ah, right. So that's lifting up there. It's lifted up there. There we are. That's it, lovely. Right. Just get that out of the way. There we go, and we can take the whole disk drive unit out of the way there. Now, The disk drives actually seem to be working absolutely A1 in this thing. There don't seem to be any problem at all with them. Both drives format fine, they read fine, so I'll probably leave them alone for the moment unless they start giving any trouble. I'll put them out of the way for now. And we're right down to the bare bones of the computer now, really. Let me get my anti-static strap. We're going to be touching things on this main board. So we've got, well, that's our LED displays there. We'll keep that safe. In fact, we can unplug that at this point just so we can get a bit of a further look down. And something I'm absolutely delighted to see, I cannot see a single surface mount electrolytic capacitor on that board. We've got a couple of electrolytics there, we've got one there, we've got one there, and they all, oh, we've got one over there. None of them look to be the type that leak. They're not like I said, the standard surface mount. They're all through-hole electrolytic capacitors, and they actually look in really, really good condition. I can't see anything there that make me any way suspicious of them. I think all our actual problem is the screws falling out. I can't see anything wrong with the top of the actual pot there. That's our little slider. That should go back on the top. And turn it until the keyways mesh, and yeah. Once I've got the keyways to mesh, that works. So let me just get that. Yep. And it gets to its stop. Push it that way. Gets to its stop. So all we need to do is find a screw to fit that, and that's the actual main problem I've got sorted. I wonder if it's in here. A little bit of plastic dropped out. No. Just make sure it's not, you know, got caught under the board or anything. Doesn't appear to be. Not stuck to the speaker or anything. Have a quick look while we're here. Maybe we can pop the speaker out. Okay, let's have a quick look. Just in case it's got stuck to the cone of the speaker or anything. No, we've not got that lucky. So what I will do, I've got to have a quick hunt around and see if I can find a screw which is going to be suitable for fitting the centre of that little pot there. Then we can screw that contrast control back on. We'll have a quick look around it. Oh, we've got another big capacitor there, 10 volt, 47,000 UF. I very, very much doubt there's anything wrong with that. In fact, you can see the bottom of it there because it's a axial cap stuck down on its end, and there's no sign of any form of leakage or anything around that. I think they use really, really good capacitors in these things. The board looks absolutely pristine. I can't see any signs of any corrosion on any of the legs. Everything looks really, really, really good in there. There's our CPU. I'll just zoom you in on that, just in case you haven't seen this this type of package for a CPU. But if we have a look down there, that little quad flat pack there with the okay, is that actually focusing? Let me get my screwdriver in there, see if I can get that to focus. Come on. I don't think the camera's going to. Let's see if we can just perhaps zoom out a little bit more. Oops, no. There we go. So basically that chip there, that Oki chip, is an M80C86A, and basically it's a CMOS version of the 8086. So that's our CPU there, and then like I said, we've got a standard 8087 mass coprocessor socket there. Right, well, I'll pause the video and I will go and have a hunt round and see if I can find a screw suitable for putting that back together. And then we can actually perhaps have a look at a tiny bit of clean up, but there's a little bit of dust and dirt round there. And then perhaps putting this computer back. Oh, then we'll have a quick check of the power supply while we're in here. It doesn't look bad at all, and it's got, like I said, it's got Nichicon capacitors, but they are 30 odd years old. And obviously in a switching power supply they're going to be under a bit more stress than the power and the electrolytics that are just like decoupling on the main board there. So I'll go and see if I can find that screw, and we'll come back and see if we can fix that, and then we'll have a quick look over at that power supply, and then we'll see about putting this thing back together. So back in a sec. Right, okay, we are back, and after a long search I finally found a suitable screw. So let's see if this will fix back on here. It is a little bit fiddly to get it in place. We've got it on there, and then we've got to get the tabs to lock down so it's right in the right place. There we go, that's sitting down now. Let's see if we can drop the screw down the hole in the middle. Of course the screw wanted to stick to the tweezers. Let's try going in from this direction. And let's try again. It's a bit like playing that game Operation when you were a little kid. There we go. Hopefully this screw is going to be long enough to actually engage, because it's the only one I could find that actually fit. There we go, yes, it's worked. Just give that a little twist. Don't make it too tight because we don't want to break the pot underneath, but we don't obviously want that screw to come out again either. Right, let's have a go. Right, hopefully I've now got a functioning contrast control on the screen. So we'll put that out of harm's way. In fact, let's just switch the soldering iron on, and we'll put that out of harm's way for a second. Let's just turn our attention to the power supply board here, and excuse me. If I don't find anything wrong, to be honest, I'm not going to change anything or touch anything because it seems to be working. But I do want to have a little sniff around the capacitors, and by sniff around I do actually mean a literal sniff around. So we'll get the soldering iron. I'll just clean the tip off that because I don't want to get any of that solder on the board. I just want to use, we could use the hot air for this even equally as well. All we want to do is have some localized heat. I'm just going to basically, oh, and I get it straight away, we get the aroma. Yeah, oh dear, yeah, we've got leaky capacitors on this power supply board, so it was well worth us going in here. We've got 470 UF at 25 volts there. We've got a 470 UF at 25 volts there. We've got a 220 UF at 25 volts there, and we've got a 150 UF at 35 volts there. Another 470 there. I bet they're thousands. They're 1800s there and there. Let's have a quick sniff around those. I'm not smelling anything. I'm not smelling anything there. No, I'm not smelling anything there. Try around this 470. Nothing there. Let's try around this 470. Yeah, we've got so with those two capacitors there are definitely on the iffy side. Let's have a quick sniff around here. Let's warm the board up. And again, no, I'm not getting the fishy smell. It's just round those two capacitors there. So what we'll do, let's get those two capacitors off the board, and then we'll have a little bit of a clean. Oh, this is going to be horrible to do as well. So we've got a negative on that side, a negative up there, and the board is silk screen where the negative is, so that's not too bad. Right, where is the desoldering pump? Let's get some solder out as well. And our first culprit is that one there. Let's add some fresh solder. Okay, let's see if we can get that out. I can already smell the bad fishy smell just by warming that up then. That's starting to come out. Let's see if we can. I think these might be quite tricky to get off because of the electrolyte, and I think this is like a few layer board as well. Just bear with me a second, folks. I might have to warm the board up a little bit before I can get these off, because there's a lot of surface mount stuff around there. I don't want to risk doing any damage, so plus I need to find my other glasses because these aren't quite strong enough to get in there for some really detailed work. So I'll say back in a sec. Right, okay, I managed to get the first capacitor off the board, and the only way I could do it, I can't really use the heat because there's just too many small surface mount components around this area that I'd have to warm up, and I'd risk, you know, potentially moving something if I got a little bit too hot. So what I did, I applied a little bit of extra solder, and I literally just heated up one side, and I slowly walked the capacitor off the board. I don't know if you can make that out on the camera, but can you see all the leaking electrolyte on the bottom of that capacitor there? It's actually wet with it, and so is the board. The board is all wet round here. So I'm going to whip that capacitor off there as well. So they're both the same value. They're both 470 UF at 25 volts. I'll probably try the same technique again. Let's just make sure we're on the right capacitor, which is... it's the other way. It's a different orientation, but it's going to be the same procedure. So let's clean the iron off again. And the electrolyte is making the iron fur up all the time, so you're having to keep the iron nice and clean. It's pretty nasty, this. So we're going to have to do a fair bit of clean up work on the board as well. We'll go in there and we'll add some nice fresh leaded solder to the pins of the capacitor. I mean, this will be leaded solder, but it's contaminated with the electrolyte, so the new leaded solder should help just lower its melting point and make it flow a little better. So I've got my finger on the back of the capacitor, and basically what I'm going to do, I'm going to warm up that pad there. And I'm just going to very, very gently put some pressure on the capacitor and see if I can see that leg moving. And we've got no movement yet. We'll just try the other one. Yeah, and that one's moved, so that one was quite easy. This has obviously got a ground plane or something on it. We'll try again. See if we can just manipulate that capacitor and get it to pull through the board without doing any damage. That's not moving yet. And we'll try, in fact what we might try is a little bit of extra flux just to help out, because this one is being most awkward. It really has been rather a tricky one. So we'll get some little bit of fresh flux on the board there just to help. I may even have to get in with some solder braid and get that crap off the iron. Right, that's nice and clean. We'll go back in. That bit's, I think that bit of flux might have just helped there a bit. Right, let's try that again now. Moved a little bit, I think. Let's try just pulling the rest of that leg out that side. And again, we'll go back in on that and we're just literally just walking the capacitor out of the board. This leg is being really stubborn, incredibly stubborn. The other side there is pretty much out. There, that side's out. So it's just being held by this side. In fact, getting that side out completely might just help us here. We can just manipulate the capacitor around a little bit more. It is very nearly out. It has nearly come out. It's just held in ever so slightly on that one leg. Let me see if I can get hold of it a bit better. You don't want to put too much force on it and yank it out and risk damaging the pad. It's slowly pulling through. That leg, the leg basically is really corroded on the other side. I can just see now where it's pulled through, so that's why it's being so difficult. I'll try adding a little bit more fresh solder to it that side, just so we get a better heat transfer through to the other side. What we might end up having to do is actually cut it off and then see what we can do about getting it out then. Let's get that side out. And I might even be able to get the iron. It's almost out. I think the solder is actually broken loose. It's just held in the hole now. Let's try it. Little bit of extra heat. There we go, gone. I don't know if you can make this out. Let me see if I can get it on camera for you. You see how that leg there, that's the leg that came out quite easily. It's quite nice and shiny and covered in solder, but the other leg is really dull. Amazingly actually, that capacitor hasn't leaked. I don't think that one has leaked at all, but I think that's just the damage from that other capacitor on the board where the electrolyte has leaked round. So, yeah, in fact I can see there that underneath that capacitor there really isn't any leakage. It was just that first capacitor we pulled out that started to leak. So, let's get the IPA out. We'll give the board a bit of a squiz down. We'll get the soldering iron out of the IPA because that wouldn't be fun. And let's have a bit of a clean up around here and see if we can get as much of that electrolyte off the board before we start looking at putting some new capacitors in there. You can see straight away it's looking pretty grim, that. So we'll have a good clean round, and then we'll go back in with the old soldering iron and have a smell test and see if we can smell any more electrolyte anywhere else. But I couldn't smell any around these capacitors here, and there doesn't seem to be any sign of electrolyte leakage on any of the component legs in that part of it. So I don't think that is. I don't think those have leaked, or at least they've not leaked yet. They will leak eventually. They will need changing eventually, but money is short at the moment, so I will just change what needs to be changed at the moment, and then in the future, if I've got some more cash, I can order up the other capacitors and we can do a full blanket recap of everything else. No, I think we've been really lucky here, and we caught it in time, because it doesn't seem to have really spread. It was literally just underneath that capacitor there that had received the spurge from the leaking capacitor. Right, I will pause the video and I'll go and have a hunt in my stocks and see what I've got. I can I'll probably replace both of them, although I think that one's probably absolutely fine. I could probably go back on the board. I might even pull the capacitor tester out and just check it, but that one is definitely not very well. So I'll see what I can find and we'll be back in a sec. Right, we are back, and I've found replacement capacitor I can stick in there. It's unfortunate, it's not a new one, but it will work and it will do the job for us. Believe it or not, the old leaky horrible one there is actually still showing okay. Obviously we're not going to be putting it back in with the state it's in, but ESR wise, I mean it's pretty good, but it is obviously leaking. I think we have literally just caught it as it was starting to leak, so that's really good. What I did have quite a bit of a nightmare. It's actually taken me quite some time was to actually clean the electrolyte off that board, get it all nice, and then get the through holes back opened up so we can actually get the new components on the board. I'm hoping this is going to go on there okay. It's the slightly higher rated on the voltage than the one we've taken off, but that shouldn't matter. It's the same physical size. So I'm hoping. The only problem is because the legs have been cut off already and they're so small, and they've got solder on them, and I have had a bit of a nightmare getting those through holes on the board cleaned out. I'm glad I didn't actually film me doing that, because it took me the best part of an hour just to get 4 holes cleaned out through that board. Let's see what those are like now. Let's give that a go. Unfortunately this doesn't work. I think we'll be having to pause this video while I get some more capacitors, or at least I have a hunt through some old boards if we can find something else that'll work. I think they should work though. No, I don't think that's going to go through the hole. Will it go through this one? Oh, we don't want to put it on that way around, that would be bad. There we go, it's gone in there. Right, so we can use that one there. Let's see if we can get, that's the bad one. Let's see if we can get this one back in here. There we go, that's gone in. Lovely. Right, so we've got our replacement capacitor in there. Let's just get them soldered into position. This must be a multi-layer board as well, because the amount of heat it took to actually do that cleanly was really more than I wanted to use, but it was the only way to get a good a good flow on that solder with it having been subjected to that electrolyte to actually get it to flow out and actually clear them holes. I involve using heat, my solder braid, lots of flux, the solder pump, but eventually I managed to get them all cleaned out. Okay, that one's alright. I just want to touch that one in. That's better. Right, okay, so that's soldered. That capacitor that was still alright was soldered back in, and we've replaced the one that was leaking horrendously there with a replacement. And the new capacitors are back in the right way they should go. So what I will do, seeing you've already watched me take all this laptop apart, I'll get everything back together and we will come back when we're a little bit more assembled, and then we can actually see whether we've made any improvements. So I'll say back in a sec. Right, well I think now is about as good a time to come back as any. As you can see, excuse me, I better just put my anti-static back on. I've got the power supply back in the actual computer, all the screws are back in, I've got the disk drives back in, and that was an absolute pain to do. Actually fitting the plastic back into the case wasn't so bad. What was tricky was getting that ribbon cable for the drive underneath actually back in, and then get everything to sit down properly. I struggled quite a bit to get that back in there, and a few choice words were said, but I managed to get it back in. So all we've really got to do now is connect back up all the cables that come to and from the PSU board up there. So there's one here. Okay, and then we've got one down here. Get that on. That's connected back up. We've got this big long one here. That's back on. Then we've got this one, which is that backup battery, that 6-volt backup battery. And that one goes in. Is it going that way? No, it goes in the opposite way. It goes in there like that. And then we've got this final connector here, which we've got to snake round there, and that is our actual battery connector for the main battery. Right, that should be it for connecting the switch mode power supply back up there. What we need to do, we need to put the keyboard back in. Now, I think if I remember correctly, the keyboard does just sit in this thing. I'll pull the little tab out there on the keyboard connector, so we should just be able to slide that back in its hole. I might have to do it this way. Slide him back in his hole like that. Being very careful. Make sure we get it in nice and flat. There we go, that's in. And then we push the locking tabs back in place. Lovely. Right, so that's the keyboard reattached. Let's get that sat back down because I don't want to damage that. That is a really nice keyboard to type on. Right, that is about it for putting these parts back together. Let's get the top cover. I've currently got the wire for the other laptop wrapped round. Get that free. Come on, there we go. Right. Oh yeah. We've got that little connector there that needs to go back in. Ah yes. Right, okay. We'll just sit this off at the side like that. And we will have to bring the keyboard back. Ah, there it is. That's what it plugs onto there. Let's bring the keyboard out of the way for a second. Everything else has been fairly easy. This is the only thing that's going to be a little bit of a mare to do. Well, apologies there, folks. Oops. And I'm kicking the tripod. Sorry, apologies there folks, the damn camera battery died. But anyway, let's continue. I finally managed to get that connector there on. So let's close the laptop and hopefully everything's going to line up and nothing's going to be in the way. Right. This is always the tricky bit, is trying to get everything back together and not trap anything while you do it. And hopefully we've got everything back in the right place. There we go, that's gone down there. There's something on that side not... That side seems quite happy. There's something on this side here. Not sit. Ah, the keyboard's jumped up out of where it should be. That's the problem. That's not quite sitting flat where it should go. Tell you what, folks. I think it's probably best if I just come back when I've got this back together and we can actually give it a test. So, back in a sec. Right, okay, I just had the keyboard ever so slightly out of place. As soon as I reseated that, it just went plump and clipped back in. So if it had carried on filming for another 30 seconds, we'd have got it straight away, but never mind. Let's get this back together. Flip it back over. Yeah, everything seems to line up quite nicely. Now, sadly we are missing one screw, so I'll have to find a replacement for that one, but I'll get all the others in. And then I think as a first test what we'll do is we'll plug the battery in and see if we can get it to boot from the battery. Because it should be able to. Providing that battery can still hold some resemblance of charge, it should be able to anyway. Got a screw there we can put in. Okay, and I think we'll just miss the middle. We'll miss the middle screw out for now until I can find a suitable replacement. That's gone in. That's gone in. Right, lovely. So we've got all the screws back in. Laptop's all back together. Keyboard's all feeling nice again. Right. I just left a horrible mark on the screen, but never mind. Take the battery. Let's put the battery back in. Obviously, if it isn't going to work, we can always power it up from the main supply, but just have a look. Oh look, we can actually control the screen now. Lovely. So we can get that screen looking something a bit more. That's much better. Oh, that's so much better. Now I can actually read that quite. I don't know, let me get you zoomed down and let me get you so you can actually see the screen. This was the whole point of this entire video, really, was seeing what we can do, whether we can get this screen. Let me get you. This is awkward because of where my camera is in relation to the thing, but can you see that? Is that actually coming out alright on screen now? Yeah, it is, isn't it? That's much better. But we can actually now control. In fact, let's try this. I've got my DOS boot discs here. We've got MS-DOS version 3.3, and this is actually the Toshiba version, so it's got all the setup and everything for the BIOS and everything on here. But we'll put disc 1 in. Press enter. And let's see if it's going to actually boot. Toshiba computer MS-DOS version 3.3. We'll put my in fact we won't put lemmings in. What we will put in is I've got PC Man here because we don't need a mouse for that, and we'll see what it actually looks like on this screen. See if it's actually good enough to play the game, because I tried this the other day on here, and you literally could not see the little Pac-Man going round. B colon enter. Second drive's working there, so let's try PC Man 1. That's much better. We can actually, right, let's press what we've got to press, spacebar for keyboard. Yeah, that's actually now, I can actually see. Let's see how quick we can. It's actually a little bit fast on this 10 megahertz. Never got the pill. It's actually a tiny bit fast on this 10 megahertz CPU, to be actually honest. Let me just but yeah, I can actually play this game now, which I couldn't before because the screen just didn't have the contrast to be able to make it playable. It was like, that was kind of like down there, and that's about as much as you could actually see on the screen. But now I can control the contrast and the brightness, and I can actually make that so it's basically usable now. So it's just a shame that the screen's failed in this area. Oh, you can't see what I'm showing you. So it's just a shame that the screen's actually failed in this area here and up the top there. But for the moment, it is, it is still usable. And that, like I said, that is so much better than it was. That really is quite nice and usable now. I've got a nice amount of range in the control. Yeah, I'm really pleased with that. Right, anyway, and as you can see, we've just done all that, and we are still running on batteries. In fact, let's see how far we can go. Let's go CGA Lemmings. Where's the mouse gone? There's the mouse. Let's see if we can actually make it so CGA Lemmings is playable. And let's also see whether this battery is going to last that long, because, as I said, at the minimum, I reckon this battery would be like 97 at the latest age it could possibly be. Load the mouse driver. Okay, and then we'll type CGA. Right, we'll call it a, to be honest actually, let's try for the Amstrad. No, because it is a Turbo XT this. Oh, let's do it as a normal one, enter. Even that looks better than it did. I can actually read F1, F2, F3. You couldn't read any of that before when I, hopefully you can see that on the screen. Let's have a play with the, yeah, we can get that so it's actually reasonably readable now, which we couldn't before. You can play about with the LCD and get something that actually looks okay. Let's press F1. Let's see if it's actually possible to play it on this screen, because it certainly wasn't before on the old screen. Even though it was just about possible to play it on my T1000 screen. So we want, just say F1. There we go, we've got just dig, press mount button. Let's see if this is actually able to be played on this computer. Yeah. Can't see my, the only thing I can't see at the moment is, there it is. My mouse scroll's a bit hard to see, but I can see all the, in fact we can have a play now so we can get that even perhaps a bit better. playing between the contrast and the brightness, you can get something that you can make everything out with. That's not bad, actually. That's playable. That is perfectly playable for Lemmings. What else have we got kicking about? Probably making the video a little bit long here, but I don't know whether that is actually working. Let's try it. We'll do an escape out of here. Escape. It should take us back to DOS. Yeah, there, we're back to DOS. I've got Prince of Persia on this disc. Let's have a quick go. Oh, let's have a... I think I've got Prince of Persia on this disc. Oh. Let's see how well this is going to work. But bear in mind, all this that we're doing currently at the moment is on that battery. We don't have the mains plugged in at the moment. That battery's got to be at least 25 years old, if not somewhat more. Okay, doesn't look terrible. For a LCD CGA, now I can actually control the brightness and the contrast. That is not absolutely terrible. Let's see if it's actually going. I don't know if this is actually going to run or not, but let's give it a try. It's still loading from disk. It might load. We're asking a lot of that battery though, we really are. That is an old battery. That's... wow! That doesn't look as bad as I was expecting it to look. Look. A while since I've played Prince of Persia. But no, that's pretty for a CGA screen. It's not even terribly laggy. Can't remember where you meant to jump to get the thing to open. Oops, and he's... oh no. Well, that's where he comes from, isn't it? Yeah, that's working really, really well. I'm like super pleased with that. Oops, and I'm dead. Anyway, I think that's where we're going to leave it. Let's get out of that. We'll do a quick restart, Control Alt Delete. Yeah, I am very, very pleased with that. So we've fixed the problem with the actual LCD screen. We now have a nice control over the LCD screen, and we've done a little bit of preventive maintenance. We found that leaking capacitor in the power supply. We've changed that. I will have to go back in the future and completely recap that power supply, because those are other capacitors, they're at the same age. It's not a case of if they're going to leak, it's basically a case of when they are going to leak. So we're certainly going to have to go back in there in the future and sort those other capacitors out. And obviously, you know, I've not done anything to the... oops. It also shouts at you if you try and shut the lid down while the computer's still on. We'll turn that off and preserve that battery. But I am stoked that that battery is actually working, even to the extent that it is. So I am super pleased with that now. I've turned this actually into something I can play about with and use and do things with and stuff. So yeah, I hope you enjoyed that little video on me messing about with my T1200, and hopefully next time we'll be getting on with something else computery. I've got some IBM XT boards that I'm playing about with at the moment, so there should be a video on them coming up soon. So I'll say hope you enjoyed that. Thanks for watching and goodbye.